So a lot of times the AP test will like to give a certain readout of like a computer program for regression lines and ask you to interpret them and know what they mean. So we're going to take a look at that today. These are the different places. First off, we talked about R squared before, and so and how to interpret it. But the R squared you want to use is the one that is just labeled R squared, not the one that's labeled R squared adjusted. We have this S, which we haven't talked about yet. That stands for standard deviation of the residuals. So if you see S and need to know how to interpret it, it's just standard deviation of the residuals. That won't be on the test. But eventually you might need to. You should know what standard deviation is. You should know what residuals are, and so you should be able to use that to interpret it. Eventually you'll get there. And then we have slope and y-intercept. Here's how you can remember which is which. In your y equals mx plus b equation, the slope is attached to x. And the y-intercept is a constant out in front. So these are going to be the coefficients. It's going to be in this column. And the y-intercept, remember the constant out in front, is the one that's labeled constant. And the slope, which remember is attached to the variable, guess what? It's attached to the variable. So that's how you can tell which one's the slope and which one's the y-intercept in the equation. And so this equation would look. So this equation will look like y hat equals the constant minus, since we have a negative slope, 0.0034415x. And then we would define the variables. So we can take this output and turn it into an equation. So that's what we're looking at today. You want to make sure this word predicted is in your, anytime you're talking about y in the equation, you should have a y hat, and it should be a predicted amount. We're making a prediction based on putting in values for x. Y hat equals, which one's the y-intercept? There's your y-intercept, negative 42.734. It's the constant. Plus our slope, which is 1.7. Again, attached to our variable. There's some other things in here that we'll talk about later on in the year, like what degrees of freedom means and these ratios and SE. Like, don't worry about those right now. We'll talk about them later on in the year. What you should worry about is R squared. So R squared, let's see, R squared is 67.8. So R squared is 0.678. And this tells me, this is a sentence that we talked about being able to write out last week. (67.8%) of the variation in y, what is y in this case? Percent body fat. Can be explained by the least squares regression line between my two variables. What are my two variables? My two variables are waist size and percent body fat. So hopefully this is a phrasing that you wrote down and that you'll eventually need to memorize. So percent of the variation in whatever y is can be explained by the least squares regression line, or can be accounted for by the least squares regression line. So again, R squared is basically how good a predictor is this regression line. If we're using it to predict y, how good a prediction is it? So what percent of that variation in y can be explained by using this least squares regression line to predict it. That's our interpretation of R squared. Well, if R squared is 0.678, well, R is going to equal the square root of R squared. So calculator time. I'll need this answer. So square root of R squared is 0.678. Which is what? 0.8234. So, quick question, because if I take the square root of a number, that could be the positive or the negative version. How do we know whether R here is positive or negative? There is a clue. Well, R squared is always positive. But R could be either positive or negative. What determines whether R is positive or negative? Or rather, what does R, if R were positive, what would it tell you? And if R were negative, what would it tell you in the scatter plot? Right. Positive or negative association. And does this have a positive or negative association? How do you know? Slope is positive. Slope is positive means positive association, means positive R. So that means that R equals 0.08, sorry, 0.8234. This indicates strength, direction, and form. A fairly strong positive linear association between the two variables. Other way. Last part. One of the men who participated in the study had a waist size of 35 inches and 10% body fat. Calculate the residual associated with this point for the individual. Observed minus predicted. Observed. So this is a formula for residual, observed minus predicted. What is the observed value in this case? So remember, observed value is whatever I got out in the data, whatever the y value is in that data. So it is 10. So what the actual data point is. Minus the predicted. Predicted, to get predicted, plug in 35. $16.766. So we're going to subtract those. To get negative 6.766. So negative residual tells me the point is below the line. It tells me the observed is under the predicted. But observed minus predicted, that's my formula for residual.